In this week, number 18, we will now be transforming our elements in a three-dimensional way. Meaning, what we will be doing is we let our elements to go into depth. And in comparison to last week, there the elements always remained flat inside the browser window. They did not go into depth. We have seen that the browser is opened on our screen. Our screen is a flat object, and therefore anything that is opened on it as well, including the browser window, and therefore flat objects only have a width which always gets represented by the x-axis, and they have a height which is represented by the y-axis, and the browser is using these two axes in order to determine where the corners of our elements are being located on our website. And therefore all it needs to do in this case is it needs an x-coordinate, how far to the right in this case, and a y-coordinate, how far down, and that ultimately lets the browser to determine the position of our elements, the corners of our elements. And the transformation types that we have gone over in last week, the two-dimensional ones, they remained flat inside the browser window, meaning all that was changing ultimately here were the x and y coordinates for the corners, nothing else. And in this week we will be encountering three of those types that we have discussed in last week once again, however in a three-dimensional way. Skewing will not be part of it once again in this week. Skewing can only be done in 2 dimensions. However, we have seen in last week that with skewing we can actually project, basically display fake 3D objects, projecting them. And in this week we will only be encountering rotation in 3D, and that is exactly what's going on right here with those elements, rotating them into depth, towards the depth. And we will be encountering translation once again, so repositioning our elements. But in this week we will not be repositioning them from the right or left side or top and bottom side, but the element itself either to go further away from us or to come closer towards us. And what we will be encountering is scaling also, but we will not be scaling the width or the height of the element. Instead, we will be scaling the thickness of the element. However, in last week we have discussed that elements do not have any thickness. We saw that when we have skewed an element to 90 degrees, then the element was completely flat and therefore its thickness was facing us, and the element was thus not visible anymore because elements do not have any thickness. However, in this week we will be creating three-dimensional objects, and once we have done so, creating them by using multiple elements, then they have in fact thickness. And that is exactly the thickness that we are then able to either scale up or to scale down. So 3 of those types we will be encountering in this week once again, and these are the values that we will be using for our property transform. And also in this week we will be going over each of these types one by one. We will be starting with rotation, and we will be applying them individually on random elements first, and then afterwards we are going into actual examples. Then we are going into translating things, and here actually translating on its own on the z-axis doesn't make too much sense. There will also always be rotation be involved at the same time, and here with rotation and translating things we are actually in that subject we are able to create three-dimensional objects, including such as, for example, square-like objects or pyramid-like objects, for example. So those ones we will be taking a look at, and once we have created three-dimensional objects, then we are able to scale them in their thickness because then they have some thickness. So that is what we will be discussing last in this week. Actually almost last, because the final part once again we will be taking a very brief look at the metrics which the browser is using, irrespective of which transformation we apply. Once again, the browser will convert it into values that go inside a metrics function. Also, what will be relevant in this week once again is the transform origin property that we have discussed in last week. And this property lets us determine a fixed point for the element from where the element shall be transformed from, so where it shall originate from, that transformation. And that point that we have determined it to be will then always be fixed throughout the transformation process. All the other parts of the element will change its x and y coordinates, it will change their position. However, that one fixed point will always stay at the same position. And we have seen we could have determined that value by once again using an x and y coordinate, because elements are flat as well. Once again, they only consist of a width and a height, which is represented by an x and by a y-axis. And since the width always comes from the left and the height always from the top, so this is our point 0 in this case. And when we are using percentage values, then this refers to the element itself, and we can therefore define any point by, for example, using percentage values. If we want this point to be the fixed point, then all we need to do is use the x value 100% and the y value 100%, which then gives us right this point. And these two x and y coordinates are then given to the transform origin property as values. And these points that we determine here, then they ultimately, as mentioned, they always determine the fixed point for the element where it will always stay at the same location. And with this property, we will be working quite a number of times in this week once again. Before we, however, now get started with our actual transform property and with those values that we can apply to it in 3 dimensions, we will first be taking a look at a couple of other properties, which includes the backface visibility and the transform style. Those ones we will be discussing in order so that we do not need to come back to explain anything, but we can immediately go into all examples and can make use of everything. And then there are also 2 other properties, and they are inevitable to not discuss first, and that is the perspective and the perspective origin. And therefore we will also be starting with them, because they allow us basically to make our elements to go into depth in the first place. They will make the browser be able to do some certain calculations, as we will now see. The browser we have seen is a flat object, and flat objects only consist of a width and a height, an x-axis and a y-axis, meaning inside the browser there is no depth at all. And therefore everything is based on calculations, how the element would look like if there was actually depth going on inside the browser, even though there is no depth. However, that depends on what distance we are looking at the element, at which distance, from what distance. So if we are closer to the element, it will look differently than if we are further away. So therefore, first of all, we need to give the browser the information at what distance we are looking at the element, so it then knows how to calculate how the element would look like if there was depth going on, upon that information at what distance we are looking at it. And also it depends on the angle at which we are looking at the element. It always depends when we are standing here with our eyes and looking at the element, or if we are right here, the element will ultimately look differently. And since everything is based on calculations, the browser therefore needs those 2 informations, the perspective, the distance, and also the angle at which we are looking at the element, in order for the browser then to know how the element would look like if there was actual depth going on inside the browser. Therefore, let us apply now a random 3D rotation on this orange box right here. A 3D rotation that is going on here as well. So on the y-axis, which we will take a closer look later on. But let us just apply now a 3D rotation on this orange box by, for example, 30 degrees. And at this given point, the element tried to go into depth, but it didn't actually go. All that was changing were its x and y coordinates. It still remained flat inside its parent container box. And that is exactly the reason, because the browser is yet unable to complete the calculation how the element would look like. It needs values for the perspective origin, the angle at which we are looking at the element, and also the distance, the perspective, the distance at what distance we are looking at the element. Now the perspective origin property, this one has already some default values, and the browser can use these values in order to make that calculation. However, the distance at which we are looking at the element is still none, and that is exactly the value that we need to change first in order for then for the browser to then complete its calculation. We need to replace that value none, by which stops the browser from calculating things, since a none value it cannot work with, it cannot do any calculations with. So let's just tell the browser, hey, we want to look at the element. We want it to look like as if we are looking at it from a distance of 300 pixels. And as soon as we have given him now this value, the browser is now able to complete its calculation how the element would look like if there was actual depth going on inside the browser. Now this value cannot be negative, and makes sense. We cannot look at something from a negative distance. That would mean that something is then behind us, but we don't have eyes behind our head. So a negative value cannot be used, nor can any relative value be used for this property, such as, for example, percentages, because the considered depth inside the browser, even though there is no depth, but that considered depth is to be considered infinite, and therefore 300% or any percentage value of infinite does not yield any result. So therefore relative values cannot be used, only those absolute or those fixed values, such as, for example, pixels or viewport width or viewport height, etc. Otherwise any relative value will not yield any calculation result for the browser. So that is the perspective, and the perspective, of course, the further we are away from an element or from anything, same as in real life, the less likely we see an effect, and meaning the less intense ultimately the effect becomes. And the closer we get to the element, the more intense the actual effect will become. Now the perspective origin property, the one that determines the angle, that one already has some default values that the browser can use for the calculation. And the default values here are 50%, 50%, which is an x value and a y value. So it's referring to the element on which it is being applied. So if we are looking at the element from 50-50, that is just referring to the center. It's done in exactly the same way as the transform origin property. We are starting at the top left of the element, and then in this case 50% on the x-axis and 50% on the vertical y-axis will give us right the center. So our eyes are looking right in the center of the element. This is what the default values are specifying. And here we can make use of any other percentage values, either inside the element or even outside the element. We can determine that those x and y coordinates. And once again, also here, same as with transform origin, we can make use of the English keywords as well. So for example, if we want that bottom right corner here, we could make it happen from using percentage values. 100% on the x-axis and 100% on the y-axis gives us this value. Or we could use right bottom, the English keywords here for, so that would also be possible. Now these two properties, the angle and the distance at which we are looking at the element, they are always being applied on the parent. So in this case it was actually the dashed border box, which is the parent of our orange box, which we have transformed in 3 dimensions. And the reason why this is the case comes now. Let us now take a look at the 2 yellow boxes underneath right here. And these 2 yellow boxes, they are sharing a common container box in which they are inside. And now let's apply a common, let's give this container box in which these yellow elements are inside, let's give that container box, it's a perspective, a distance at which we are looking at it. And let's take a look how the element will then ultimately be transformed in 3D once we also rotate it in 3D in the same way as we have done it with our orange element. By 30 degrees, and we can now see that the elements do look differently. And that makes absolutely sense. It is the realistic view that we have from this world. Let us therefore take a look at an image right here. There are 2 rails. Let's concentrate on the left rail. And each rail consists of 2 parts. It's the right part and the left part. And if we are following those 2 parts of the rail, then at one point it seems to be that they would cross over, that they would intersect in the far distance. And that is the realistic view that we have from this world, even though, of course, and hopefully, those 2 rail parts will never intersect. But that is just the realistic view that we have. And let me now change the transform origin so that we are looking at those 2 elements from somewhere down here. And as soon as I have saved it and we are reloading the page, this is exactly what is going on right here as well. These 2 elements look different. They will intersect. If their width would go to infinity at one point, they would intersect. Even though it will not be the case, but that is the realistic view that we have from this world, so they cannot look the same. Since we have applied the angle and the distance on the parent element, so we are looking at them right in the center of the parent element, and since this one is further to the left and since this one is further to the right, or even if there was another element even further to the right, they would all look different since that is the angle at which we are looking at it, and those further to the left and further to the right will just look different. It's exactly the same thing as in real life. And often it is the case that we want multiple elements to share a common angle and a common distance at which we are looking at them. And that's exactly the reason why we are applying the perspective, the distance, and the perspective origin, the angle at which we are looking at them, on the parent elements. However, the perspective actually can also be applied on an individual element as well. So what we have here is the perspective function that can be given to the transform property actually. And it determines exactly the same thing as the perspective property. It determines the distance at which we want the element to be looked at. And in this case, let's apply it, and this one gets applied at the transform property, right where the transformation is being applied as well. And here we can give now, for example, let's give it 300 pixels. In this example, let me outcomment the other ones, the perspective and the origin. And as soon as I reload the page, it is still working. So the difference between those two is really when we have multiple elements and we want them to share a common perspective and an angle, then we are going for the properties and always apply them on the parent. If we have only a single element and we do not mind about changing the angle, because the angle cannot be changed once we are using the perspective function. It doesn't matter what we change now those values to, it will have no effect at all on the element itself. So really only when we have no other purpose other than looking at the element from the center and only want to transform a single element with a certain perspective, with a certain distance, then we are going for that function, otherwise always for the properties that we have available. For example, if we are going for a shape, we have seen how to create such a shape. It is just a circle, a transparent one, which we can give a border only on the left side, which will then ultimately give us such a moon-like shape. And sometimes it happens that we want to place a certain shadow on a circle or any other square box or something in order to give it some kind of 3D appearance, even though it's still 2D, just a little shape for a shadow or something. So that would be a situation where we would, for example, go for the perspective property, the perspective function, and apply it directly on the element. Since we do not mind about the angle at which we are looking at it, we only want to use it in order so that we can create a different shape. Otherwise, we really don't mind. So that would be a situation, for example, where we would go for the perspective function instead of the perspective property. But in this week, we will only be working with the perspective property, and that also allows us then to make use of the perspective origin, because that one has no effect once we are using the perspective function. So in this week, we will only be working with those two, and those two, therefore, they do always get applied on the parent element, so that multiple elements can share a common angle and a common distance at which we are looking at them. One more comment I want to make about the perspective origin, because this one is defining the angle, the point at which we are looking at the element, but indirectly or directly it is also specifying the so-called vanishing point. Let us therefore go once again into that image. And images are two-dimensional, as we know. They are only projecting 3D, but however they only have a width and a height, nothing else. They consist only of two axes. So in this case, that would be our container box, for example. And now inside this container box, there are quite a number of skewed parts inside that image, which are just skewed, not being three-dimensional. And if we are, for example, following those rail lines to infinity, we will find out that here we can actually find out where the image was taken. It's the angle, right? The angle at which the lens of the camera was looking at when the image was taken, and indirectly exactly that point is also determining the vanishing point, because at this point everything, if everything would go to infinity, this is where things would disappear at one point. So that is why it's called the vanishing point. And here, for example, that 3D box right here, if we follow its line, it would ultimately also get there, and anything else that's three-dimensional facing into that direction. And therefore, the perspective origin, the values that could be used here, or that would be used here, were on the x-axis, 30% maybe approximately, 25, 30, something like this. And then on the y-axis maybe 5% down. And that is exactly where our eyes are looking at, or where the lens of the camera was looking at when the image was taken. So that person was standing therefore right here, and that person had a physical height either, or most likely that person was standing on a bridge under which the rails were running underneath, and the lens were facing right at this point, and then the image was taken. And that vanishing point can actually only be seen when we are really dealing with three-dimensional objects. So once again, let's take a look at this one, and let me also now make those lines to go to infinity, or at least longer than they actually are. And once again, here we can see that all of them will meet at one point. And if the elements would go to infinity, all of them, the page 1, page 2, etc., page 4, if they would go to infinity, that is the point where they would be disappearing at. So it's the vanishing point at the same time. It's exactly the point at which we are looking at. So the perspective origin is it. So this point is in here, 50% on the x-axis and approximately maybe 80% down. That is the value. So physically we are standing right here, and we have a height so that our eyes are right facing to that point. That is how we are looking at this entire website at this given point. That's how everything was laid out according to that point. So this is the perspective and the perspective origin. Both of these properties get always applied on the parent element, so that multiple elements can have a common perspective, a common distance, and a common angle at which they are looked at. Let's go into two further properties, and these are very simple to understand. The first one is the transform style, and this one will always be relevant to us once we are transforming a parent element in 3D, and then its child we will be transforming as well in 3D. And then whenever that is the case, then we need to change the transform style value that is being used by default. Let me now give this orange container box here a rotation, same as we have done it just in the other examples. So rotating it on the y-axis by, for example, 30 degrees. And of course we need a perspective, and the perspective must always be given on the parent container box, which is the dashed one with the dashed border. So I have given it already a perspective right here. Let me reload the page, and I have used the wrong one in this example. This is the orange box. And here we go. Now the orange box has been rotated. It does not remain flat inside its parent, but instead it can go into depth, and it can intersect its parent container box as well. Now the child element that is inside here is being transformed always as well. Any content inside a transformed element will be affected as well, as we have discussed it in last week. However, if we now want that element, that child element, the green box here, to have its own three-dimensional transformation from where it is already being transformed due to the parent transformation, then we need to change the value. Otherwise, it will remain flat inside the parent. The same situation as we had before above there when we didn't apply a perspective. Nothing will yet change. The element became smaller a little bit. It tried to go into depth, but all that was changing were the x and y coordinates. So here, once again, we need to tell the browser, hey, continue your calculation also for the children. Make them to have their own 3D space. So make them to also make them to be transformed in 3D on their own as well. And the default value that's being used for transform style is exactly what is going on here. It's flat. And here we need to tell the browser, preserve that 3D effect for the children. And once we have done so, then now the green box or any children that are inside here can then also transform in 3D in their own way. So it's once again based on calculations that the browser needs to do, and we need to tell him whether we want things to be calculated, so the browser does not do any unnecessary calculations here. So here we need to change that value away from flat to preserve 3D. Now the transform style property is always being applied on that parent where the children are being inside that are being transformed in 3D as well. So that 3D transformed parent, that is where the transform style property gets applied to. In comparison, the perspective and the perspective origin must always be at the outer parent before any three-dimensional transformation happens in the first place. Let's go on, or one more comment actually, a pity comment for this transform style property, since the Internet Explorer is not supporting it, the latest version of Internet Explorer. Now the latest Microsoft version called Edge is supporting it, but the latest IE version, which is 11, does not support it. A very great pity. We have two examples in this week where we will make things so we do not need to use the preserve 3D value. However, it will almost in all situations it will be necessary to make use of it. So meaning those people who are using a Internet Explorer 11 version and are then visiting our website, then they will not see the effect since it is not supporting it. So that's a great pity. Besides the object fit property, most likely those two, besides one more, it's the greatest obstacle at this given point in regards to CSS properties that are not being supported by Internet Explorer. Let's go into backface visibility, the last property before we are then getting started with actually transforming into 3D. And the backface visibility, very simple to understand. All it determines is when the element is showing us its backside, then we can determine whether it shall be visible or the element shall be visible or not. So first of all, when is an element showing us its back? Of course, when we are rotating above 90 degrees. And as soon as we do so, then it shows us its backside. And here, at above 90 degrees, it will, from that point onwards, it will show us its back. And here we can determine whether, as soon as the back side is facing us, whether we want that one to be visible, which is the default value that's being used for backface visibility. And alternatively, we can tell the browser, hey, please hide our elements once the back becomes visible, and that happens at 90 degrees. And also one more comment here in terms of cross-browser support, which is most likely something that we do not need to worry about anymore when we are watching this video. But currently, since transformations, they have lost their prefixes not that long ago, and Safari hasn't yet removed the prefix. So for Safari, we still need to do it. So it's still kind of an experimental property that is being used here. So what we need to do is we need to use the prefix version here as well for the Safari browsers. So WebKit transform WebKit backface visibility and then hidden. So that one would then be only for the Safari browser, since it yet has not removed the prefix version. Let's go on into actually now transforming our elements in 3 dimensions. And we will now be starting with rotation. And the first rotation that we will now be taking a look at is once again the rotation around the z-axis. Because once again I want to bring across why it's actually referred to as a z-axis, because this one we have already accomplished in last week. Since it is a 2-dimensional transformation, the element still remains flat inside the browser window. Only the x and y coordinates of the corners are changing. The element does not go into depth. But why is it referred to as a Z rotation? Once again, let's take a look at the x-axis. Of course, it's our horizontal one. The y-axis is our vertical one, and the z-axis is actually going into depth right at this red point here. But it cannot be drawn this way, neither could it be seen this way then. So therefore, it is just a common way to draw the z-axis a little bit further away, so that it can actually be drawn and also be seen by us. And now let's assume that we are hanging on to the z-axis, and let's not forget the z-axis is going into depth right at this red point here. And if we are then rotating around it, we are rotating like a propeller, and this is exactly what's going on right here. So it is a 2-dimensional rotation. It has received its name Z because we are hanging on to the z-axis, so that is where it has gotten its name from. And once we are rotating around the x-axis or the y-axis, we are in fact going into depth. These are 3-dimensional rotations that we will now be discussing. Let's take a look at rotate x first. And this one I have given already a value here, 30 degrees, meaning a positive degree value. And once we are using a positive degree value, the element will fall backwards. When we do use a negative value, the element will therefore fall towards us forwards. Now, in regards to rotating on the y-axis, here it's straight again our same pattern as usual. So when we are using, for example, the left or the margin left property with a positive value, we are moving the element further to the right. Negative will move it further to the left. So once we use a positive value, the element will rotate to the right, exactly the same pattern. Once we are using a negative value right here, it will rotate to the left. And what we can also do here is we can do things simultaneously on multiple axes when we want an element to rotate in the same amount of degrees. So then we can actually make use of that shortcut right here. And this one accepts 4 values. The last value is representing the amount of degrees that we want the element to rotate. For example, let's go for 40 degrees, for example, or maybe for 30 degrees. And the first 3 values will represent the X, Y, and Z axis in alphabetical order. At this given point, nothing has yet happened, since the values are by default a 0, and we can change them to, for example, 1. So the x-axis value is now 1, referring to once 30 degrees in this case, and the element is now falling backwards by 30 degrees. Once, for example, we also give now the y-axis a1, then it's also rotating around the y-axis by 30 degrees. So we can do things here simultaneously on multiple axes. And once we, for example, use a negative value, then we are rotating the opposite degree value that we have specified right here. So on the z-axis in this case, or let me do another example, or let me do it on the y-axis, we are rotating therefore to the left in this case. So negative here is always to the left. So that is what we can use here, and this does things simultaneously, meaning for each little bit of rotation that's going on the x-axis, there will be at the same time a little bit of rotation on the y and on the z-axis. In comparison, when we are using the transform property as we have seen it in last week, here we specify multiple values one by one, and that one by one is exactly the key word always here, since the browser calculates the end position for the element by first rotating the element on the x-axis by 30 degrees, and then from that position, from that look, it will rotate it on the y-axis. So things do not happen here simultaneously, and therefore that ultimately gives us a different result if I would go for negative degree values here, but it would still look different. Let me once again outcomment this one. So once I reload, it is a different look due to the fact that here things happen simultaneously and here things happen one by one. 2 more comments I want to very briefly make here in regards to 3-dimensional rotation. One comment is actually in regards to rotation in general, and that is hopefully and most likely something that we don't need to consider anymore once we are watching this video. Something that we have discussed last week, that rotation causes some jagged edges on the sides, and we can remove those, or we can cover those jagged edges by using a transparent outline. Outline is always outside the element, and once we use a transparent outline of solid 1 pixel, then it will cover those jagged edges, and therefore the sides will be made smooth once again. So that is only happening still in Firefox. It used to be in other browsers as well, but most likely Firefox will have solved this problem soon as well. Now another comment that I want to make is in regards to the transform origin. Since with this one we determine the fixed point where the element shall remain fixed throughout the transformation process. Because here things, the default values that are always used are 50-50, and that is referring to the center. So right now, around the center, the element is being transformed. That one is the fixed point. And if we want the top left corner or any top side here, it doesn't actually matter which one we are using. It just must be at the top. So meaning the x value can be anything, doesn't matter. Just the y value can be different, but it must be at 0 at the top somewhere. The y value doesn't matter in this case. Let us just take a look at this one. So let me change the y value, for example, to 0, meaning the point that we have now defined is 50, 0 right here. And that will now be the fixed point. But since the entire top side is there, so it doesn't matter, we could go on the x value to 0 as well, that one will not change anything. It will always be the same. The entire top side is always, the x value can be anything. When the y value is 0, the x value doesn't matter anymore. Or even when the y value is somewhere in the middle, the x value can be anything for rotate on the x-axis. Same with rotating on the y-axis, just referring to the other side, to the right side and to the left side. So when we are using here a value, for example, on the x-axis of 0 and on the y-axis of 0, that will ultimately give us the top left corner to be the fixed point. But it doesn't matter since the entire side is always there, so we could use any y value as long as the x value is 0, then it will always be on the left side. So that is just something special here in regards to these types of rotation, since the entire side will always be at one location then. Let's go into actual examples, and the first example that we want to take a look at is this one here. As soon as the mouse is hovering over this element, it will flip, and then the backside it will shown to us, and there will be backside content. So in this case, what rotation is going on here? It is going to the right, so therefore it's the y rotation, and since it's going to the right, it's rotating to the right, so it's a positive value. But it doesn't matter whether we are using positive or negative, and it also does not matter whether we are using the x-axis and flip it this way with a positive or negative value. It's all based on the same logic. So let's just go for rotating it on the right, on the y-axis to the right. Let's go for this one, and then ultimately we take a look at the other options as well. Everything is based on the same logic. Let's take a look at what we are dealing with here, since it is not really possible to create any back content. We know the element opens here it closes whatever is inside, that's the content, and we cannot tell the browser, hey, this part shall be the back content. So we can only do things indirectly here by creating just another element, and one shall represent the front side, the other one the back side. We put them on top of each other, so that yellow one shall represent our back side in this case, and underneath is the front one, that one is representing the front side. So in order for them to be on top of each other, therefore these two elements are position absolute. And what we ultimately want, when the parent container box is being hovered over, then they shall ultimately rotate to the right on the y-axis. And the parent element, I have made the relativity point for those two absolute out of flow elements. So this one is position relative. Let's take a brief look at the CSS setup that we are dealing with here. So the parent element, I have given a certain width and a height, position relative, so that the children that are absolute on top of each other, so that the values 100% for width and height refer to the parent. They therefore have the same size. And let us now concentrate first of all on the back, on the front part. So meaning on our red element here that is representing the front. And when the mouse is hovering over the parent container box, then we want the front part to rotate to the right on the y-axis, and of course by 180 degrees until it is then showing us exactly the back side, since one rotation of course is 360 degrees. Now let's make that also happen over time. So let's give both children that are inside here, the front and the back, let's give it a transition, meaning whenever the CSS values for those two elements change, then it will happen over the duration that we have specified here, which is 2 seconds. So as soon as we reload the page, now this is working, and we have already a nice effect, and that is exactly the effect that is going on here. However, that is not yet a three-dimensional flip that we are doing. The element cannot yet go into depth since we haven't yet defined a perspective value which the browser needs in order to calculate how the element would look like if there was actual depth inside the browser. So the element is yet unable to intersect with its parent element. It cannot go into depth. We first need to give it that perspective, and of course on the parent element before the children are being transformed. Let's do it, for example, with a value of 500 pixels. And as soon as we have done so, then the element can not only remain flat, it can then go into depth now. And that is the effect that we have now gotten here. So that's already the final stage for this one. Let's now concentrate on the back side instead. And the back, of course, from the beginning shall show us its back, since it is representing the back side. So therefore, let us rotate it even before the mouse hovers over its parent container box. Let's already rotate it around the y-axis by 180 degrees. So from the beginning, it is now representing the back. And when now the mouse hovers over the parent container box, then the back child, shall then rotate, it shall complete its full rotation from 180, it then goes to its final 360, so that it then shows us its front once again. And as soon as we are now hovering over with the mouse, this is accomplished. And now everything should be fine as soon as we now also uncomment the front element. However, it is not yet completely done. And it makes sense, since only the one element will be visible at this time. Because both of these elements we have taken out of the flow. However, we did not hand out any z-index values by which we can determine which one shall be on top or at the bottom. So by default, always the latter one inside the HTML code, which is out of flow, will then be on top, and that is the back one. And the solution is also not to hand out any z-index values, because if we would hand out a z-index value, a higher one for our front element, then it would always be visible and the back one would never become visible. And therefore we will now be making use of our new property that we have introduced, and that is the backface-visibility property. So here we can tell the browser, hey, whenever an element is showing us its back, we don't want it to be visible. And now at this given point, from the beginning, it's the yellow one. So let's change it to hidden, so the yellow one from the beginning will be gone, and only the red one will be visible, since it is of course showing us its front side. However, as soon as it reaches 90 degrees, it will then be hidden once again, because then it is showing us the back side. At the same time, the yellow element, as soon as it reaches 270 degrees, it will then show us its front, and therefore it will become visible. So that is our final result that we have now accomplished here. Let's go into our next example, and here we want to accomplish a book page flip, and then for the next one, very similar, it will be the calendar flip. So let's do the book flip first, and what we are dealing with here once again is a container box which consists of the front and the back, and once again we want the back side to already be rotated. And what we have done in the previous example, we have rotated everything around the center when the mouse hovered over it, and also before the mouse hovered over the element, the back side, we also already rotated it from within the center so that it then was showing us the back side. However, let us now go into an actual book flip, what that one would actually look like. So what we are dealing with here is a page, and that page consists of a front and a back. And if we want that page to flip now, we need to change the transform origin point to somewhere to be here. So it doesn't matter, as we have just seen, somewhere. So the y value doesn't matter as long as the x value is 0 for the transform origin property. So it doesn't matter, let's just make it 0, 0, leave it at the top. And as soon as it is right here, then the element will actually rotate right over to that side. But the point here is that when the mouse will then hover over the element, we want the transform origin to be on the left side. But from the beginning, however, we are already, even before the mouse hovers over it, we already want the back side to represent the back. So we want that one to rotate already as well. But that rotation we want to happen from within the center. Because if we don't do so, let's just take a look at our previous example once again. If we don't do so, then it won't be attached at the back. Instead, let's go, for example, for 0 on the x-axis. It will then be already on the side, but we want it at the back. So for this back element from the beginning, we want that rotation to be, that transform origin to be in the center. But then when the mouse hovers over it, we want it to be on the left side, and that of course is not possible. We cannot give a single element two different transform origin values. One for when the mouse hovers over and one before already. Just does not work. So what we are dealing with here then in this case is another container box. And what we will be doing, we will rotate our backside in the center. We won't change the transform origin value here since it happens by default in the center. And then what we will do instead, when the mouse hovers over the outer container box, then we will be rotating the entire page, which includes the front and the back. Because on that one we can then determine another transform origin value. It's another element, of course. So that is therefore why we are dealing with a different setup here. And ultimately, of course, we would use that container box anyhow, because a book, of course, consists of multiple pages. We are just now working with one single page. And each of these pages, these multiple pages, would be stacked on top of each other as well. So this one will be a position absolute, and these two position absolutes, so that they can be on top of each other. And let's make the relativity point now the outer container box right here, which is the book pages, the plural pages container. And that's the book page singular container. And each singular container box here consists of a front and a back. Let's take a look at the CSS setup that we are dealing with here. So what we will be doing now, we give the outer container box the perspective. So the pages container, the plural one. And now the book page container will be the one that we will be giving a transform origin to happen from the left side. So we are achieving this book flip to the left. And therefore also the transition we will be applying on here, because we will now be flipping the book, the container box of the front and the back over time, and not the individual front and back individually. And we want that to happen as soon as the book pages container, the outer container box, gets hovered over. Then the book page, which includes the front and the back, that one shall then be transformed. It shall be rotated. And since we are going to the left here, we are doing the page flip to the left, so negative degree values, therefore 180 degrees. So let's take a look for now what happens, and this is ultimately what we have accomplished. And however, the backside currently is visible, and of course that is not what we want. The backside currently is always on top, since we did not hand out any z-index values. First of all, let us rotate now the back. Let's give it a rotation of 180 degrees. And of course, for this one, if we don't define anything, the transform origin will be within the center. And that is exactly what we want. And once again, we don't want it to be visible when the backside is facing us. So both of these elements, the front and the back, we are giving backface visibility hidden. And now it should actually work. Almost. There is just one thing to consider. And that is that here it is not yet working, only the front side is yet visible, since what we have just done is we have, when the parent container box gets hovered over, then this one will be transformed in 3D, this one will be rotated. However, that one was rotated from the beginning, the backside was rotated from the beginning as well, meaning we have applied a three-dimensional transformation on this one, on this child, as well as on the parent. And whenever that is the case on the parent element, we need to tell the browser, hey, preserve the 3D effect, let the children have their own 3D space. So on that book page container here, we need to tell the browser, preserve the 3D effect. And as soon as we have done so, now we are actually having that actual effect accomplished that we wanted to have. Now, very simple here, whether that be for our first example or for the example that we have just worked with. If we want to go into the other direction, what we need to do, of course, we need to rotate to the right. So negative values, ultimately, sorry, that's the wrong one. We want to rotate to the right, so positive values, 180 degrees. And of course, we need to change the transform origin. So we want it to be x-axis to the right. On the y-axis, once again, it doesn't matter, but the x-axis value must be 100% on the right. And now we are rotating, we are opening that page, we are rotating that page to the right. Now, obviously, of course, we would ultimately accomplish this effect when the user who is visiting our website clicks somewhere. But since we do not have access to any click events, that can only be accomplished with JavaScript. So, of course, to ultimately have the final effect or the final setup, we would need JavaScript for. But that is already the setup, how things are accomplished, irrespective of JavaScript at this point. Also, once again, let me go back for a very brief moment to our first example. So let me set that hidden once again. And here what we could have done as well, we could have just used negative values, of course, instead. And then we are going to the left side instead of going to the right side. Of course, what we could have also done, could have just changed all this to rotating on the x-axis, meaning letting the element fall towards us in this case with a negative value, or fall it backwards with using positive values. So it's always the same logic that's going on here. And it will now also be the same logic for our next example for the calendar. And the calendar here, where we want the rotation to happen, of course it shall go this way, so this one shall fall down. So therefore we are dealing with an X rotation in this case. And the transform origin must somewhere be on the top, so the X coordinate doesn't matter. The important one is that the Y coordinate remains at 0 for the transform origin property. But here somewhere at the top, because here things are stuck together by those rings. Same as with the book, here things are glued together, so it must be here somewhere. So therefore the Y value remains at 0, X value doesn't matter, and that is what we are now going for in exactly the same way. So when the outer parent container gets hovered over, this one will be rotating instead, and that includes both of the children. And from the beginning, the backside will be rotated as well from the center. And on the parent, when it's rotating, we will be changing it to the mentioned transform origin value. Y value must be 0, somewhere here. 0, 0 is fine. So for transform origin. And of course, the outer container box gets the perspective before any transformation goes on. And this one gets preserve 3D, the transform style. So always on the parent telling the browser, hey, any children, here this child in this case is also being transformed. It shall preserve its 3D effect for that child. So let's go into the CSS. So very simple, very briefly, the outer container box, the pages container, the plural, gets the perspective. The individual page that consists of the front and the back will be rotated over time, so it gets the transition. The Y value must be 0, X doesn't matter, we could make it anything here, doesn't matter, let's just leave it at 0, it shall just happen at the top here. And then here also we want the 3D effect to be preserved for the children, since we are also doing it, or also transforming the child here already from the beginning, and it shall happen from within the center once again for the backside. And when the mouse now hovers over the parent container box pages, the individual page that includes the back and the top will then rotate by 360 degrees. And and on the x-axis, in this case, since it's a calendar flip. And of course, whenever the backside becomes visible for each of these elements, for the front and the back, it shall then be hidden. And once we have done so, we now have our calendar flip. That is still our book one. Here is our calendar. Let's go away from flipping things and let's do one more example in regards to rotation. And the example that we now want to get accomplished is this image right here. When the mouse is hovering over the parent container box in which the image is inside, then the image we want it to fold together. And that one is made up of multiple elements on which the same image is being applied upon. So what we are dealing with here is actually 1, 2, 3, 4, and 5 elements. Because the second element is rotated on the y-axis to the left, so negative. The fourth one as well to the left, negative. The third and the fifth one are rotated on the y-axis to the right, meaning with a positive degree value. And the first one just remains the same, it stays there. That is now what we want to accomplish. So the setup is here, so we already have the container box and there are 5 boxes inside next to each other. So they are inline level elements. Let's take a look at the HTML setup. So one container box and there are 5 container boxes inside. And since they are inline block, they will be treated as text by the browser. So there will be a white space by default in between. So I have removed that one by default, removed that one manually here already. Let's take a look at the CSS, how we can now get the image first of all into place. Let's give all of these boxes, all the div elements that are inside that container box, let's give it a background image. The same one that we have already worked with. Now the background image will always start at the top left. since the default values that are being used for the background position are being 0, 0. And the image always comes from the left and from the top. The height comes from the top and the width from the left. So the 0 coordinates for the x-axis is right on the left, and for the height, same thing. It's right on the top, therefore at 0, 0. Now that is fine for the first image, and however for the second image, we want the image to start further to move further to the left. So we want it to start further at the right, but the image actually shall move further to the left by the amount of the width of these elements. And I've given them a width of 110 pixels. So meaning in this case, for the image to move further to the left, we will therefore be making use of negative values for the x value for the background position, and by negative 110 pixels. So that image from here inside that element will then continue from where it left off inside here. And here once again further 110 pixels, so 220, 330 and so on. And that will ultimately make it look like as if we are dealing with one single image, even though of course it's made up of multiple elements. Just the background position is being changed so that the image ultimately always continues, and it will look like as if it was one. Now let's go into that transformation on the y-axis. Let's use a degree value of 35, for example, and we have seen here once again, so the second part, the second element and the fourth one, they shall be rotated on the y-axis negative, the third one and the fifth one positive. So let's go into when the mouse hovers over the parent container box, then the second image shall rotate negative when the mouse hovers over, and then the fourth image shall also go negative on the y-axis, and the fifth and the third one, they shall go positive on the y-axis. And of course what we also need here is a perspective, first of all, so that the elements do not remain flat inside their parent, but the browser is then able to calculate how the elements would look like if there was depth, so it can actually make them go into depth. Now what we need to do here, of course, since that first element remains normal, it has here its normal height still, and this one has changed its height in this case. However, we want that height to directly attach, of course, to that left, to the previous element, the previous image. And therefore we want that height to remain the same. So what we need to do therefore is change the transform origin to somewhere be on that side. Let's just go for 0, 0. So the y value doesn't matter as long as the x value, it must be on the left side. And then this one will always stay there. Therefore it will stick, it will remain its height so that it will have the same height and it can then attach to its previous image. So the transform origin we will be changing for this one now. And we will be changing here on, it doesn't matter, 0, 0, as long as it is on the left side. And here we go, here it is now attached already. Now the next one, we want that side, of course, to attach to here. So that side must be at its highest point here. And therefore we will be changing now the transform origin to be on the very right side. So the x value is relevant 100%, the y value doesn't matter as long as we are using going all the way to the right, the left, doesn't matter whether we are using 0, 50. And now its highest point is on the left side, and it can attach to its previous image. Now the next one, once again, we want it to happen at the left side, and once again for the next one, we want it to happen at the right side, the transform origin. We want the element to be transformed from the left and the other one from the right side once again. So here we could go for 0 or 50, doesn't matter as long as it is on that one side. And that will give us now that result at this point. One thing that we now need to do, of course, is we need to move the elements further to the left, or at least the third one, the fourth one and the fifth one. Since, of course, once we are rotating an element, it will, at least on the y-axis, then it will have a smaller width. It occupies a smaller x coordinate. It will be smaller, the corners or the entire element, than it used to be before. So therefore we need to move it to the left. And how do we move an element on its left side or right side? So therefore we will be making use of translate x. The translate x function, the two-dimensional transformation function that we have gotten familiar with in last week. Now something very important to consider, we of course need to make that translate x we need to move it further to the left before the transformation, before the rotation happens. We have seen it last week because it's referring to the element itself, the translation always. And when the left side of the element is already being rotated, it's facing a different direction, and that is then the direction that it will then move to. That is then its x direction. So it will then go into a completely different direction. So it must happen before we rotate it. And now the question, of course, becomes how far is that gap? By how far do we need to move it further to the left? Now this gap that we have here is actually the gap that this image produced, since it became smaller, and it's one half of that gap, and the other half came from that image that became smaller as well. And we have discussed it at the end of last week. There is sometimes a little bit of trigonometry involved here, the study of triangles, and without having that pre-knowledge, without having really to need that pre-knowledge, let us just follow now a common rule here. So if we want to find out the percentage of how wide the element is now from its previous width, we are going for cosine. So let's go for cosine and let's just calculate it. Cosine and the amount of degrees, cosine 35. So let's go for 35 and the cosine, and that ultimately gives us the result. The element has now a width of 81% of its original. So meaning we first need to do a little bit of calculations here first in order to get the actual width and the gap in pixels. So 81% of its original. So therefore, let us now calculate this for a moment. So its original width is 110. And that is representing the 100%. So let's divide it up by 100. And then let's multiply it by those 81.9%. And that ultimately gives us the pixel result at least. At least it gives us the pixel result of its current width. But we want the gap, not the current width, but the gap that was produced. So the opposite. So let's just negative 110, and that ultimately gives us now that gap that each individual image produces. Therefore, since now we are dealing here with a gap from both images, so 2 times that, we need to multiply it, of course, by 2. So let's just do that for a moment, multiply it by 2, and that is now the amount. So the point here is, without having to have that knowledge in the study of triangles, it's cosine to use. Cosine, and now we have that value. And I have already inserted it here, so to keep it a little bit shorter. And once we have done so, it's directly attached to it. The next one, of course, we need to move it, those 2 gaps as well, to the left. Now here, the next one is actually 4 times that gap. It's the gap from this one, from the second, from the third, and from the fourth, meaning 4 times that gap. So 2 times that amount that we have used previously. So 2 times 39 something gives us 79. And that ultimately gives us the final result here. If we would have accomplished now the exact same effect just going the other way, so if we would have set up 5 boxes on top of each other, and we would have given these individual boxes now the same background image and done the exact same effect just in a vertical direction, we would have made use of rotating on the x-axis, of course. But here the same thing. Once we are rotating on the x-axis, in that situation we would want to know the new height of the element. So what's the percentage of the height once it's being rotated? And once again here it would also be cosine. So just for a general rule to remember here, if we want the new width or the new height, it's cosine. We are going for the cosine and the amount of degrees that we have made use of course. In our case it was 35 degrees. Let's move on into translating things to our second type. And here we will first once again apply it on random elements first. And on the orange box will be our first one. And let's translate it on the z-axis. And in this case, we are not moving the element from its left or right side in regards to the left or right side, or in regards to the top and bottom sides, which we did with translate y. Or translate x just in the previous for the right and left sides. Now we are referring to the entire element basically, to its entire thing. And once we are using now a positive, at this given point, a positive value, the entire element will come closer to us on the z-axis. And now if we are using a negative value, it will move further away from us. And now comes the crucial thing once again. the crucial thing to understand here. Because once we rotate the element, since the translate values always refer to the element itself, it will always depend what those translate z, where it will ultimately move to. So the z-axis, it's not referring to the z-axis. The z-axis is always going into depth. It's referring to the element, the entire element itself. So that is the crucial thing to understand here. Let's rotate it now on the y-axis, for example, by 30 degrees once again. So that rotation that we have now done quite a number of times. And now let's translate it, and we will find out that it's now moving this way. So it's negative value, so we are moving further this way. But that is the crucial thing to understand here, in order to understand the coming examples as well. So once we, for example, rotate it so that the backside will become visible, and once we translate it with a negative value now, it's not moving further away from us, it's actually moving further towards us. So that's really the crucial thing to understand. It's not referring to the z-axis, it's referring to the element itself, to the entire element. So whether we are using positive or negative value just depends which side of the element is facing us. So now positive values would actually now go further away, make the element go further away. That's what we can also do here. We can translate things on all the axes simultaneously. And so on the x in the alphabetical order, divided up by comma, x, y, and z. So let's just go for 20 pixels, for example, on the x-axis, then 50 on the y-axis negative, and negative 100 pixels on the z-axis. And here now all three translations, repositionings, have been applied on all the three axes. Now whenever we are repositioning things, it doesn't matter whether things will be calculated, whether the end position of the element will be calculated simultaneously or one by one, it will ultimately get to the same result. Since whether we translate first by 10 pixel, for example, on the x-axis and then do the remaining things, and then do another 10 pixel on the x-axis, it will just always move to that point. It will always be the same. It does not matter whether we do things simultaneously or one by one. Of course, obviously, this one would be shorter, that option that we have right here. Let us now go into actual examples, and we will now be following one common way of doing things, since we will now be building 3D objects. And the way we will always be building them, even though sometimes it may be simpler in doing it in a different way, or simpler, not simpler, but less code at least. But to have it simpler, we will now always do one same procedure. We will follow the exact same procedure. The first example that we want to accomplish is one of those circles. It's actually a polygon ultimately. It consists of 8 sides. If they would be next to each other, we would have that shape, a polygon. So it's just we will now be building 3D objects therefore. Now let me give this one actually, let me bring it to a different location. So what we now want to achieve first, we want all the elements that make up that polygon or that circle here. All the elements we will first bring to the center on the x and the y and also on the z-axis. And that is the procedure that we will be following throughout whenever we are now building 3D objects. We will first bring them to the center on all 3 axes, meaning we will stack them all on top of each other at one given point right in the center. And from that point, which is right here, we will then move them out to their actual location where they shall be, but from one point from the beginning. Now, one round here is 360 degrees. So what we need to do if we are really working with 8 elements, 8 boxes, then we need to divide them up by 8. 360 divided by 8. So once they are all in the center, then we move them out always by 45 degrees more. This one 45, this one 90, and so on, which then ultimately gives us 360 degrees. And since we are dealing with 8 elements, or since and the depth we determine to be, let's go for a random value here. Let's go for 600 pixels that we want the depth. Meaning, first of all, we will move our elements 300 pixels into depth so that they are all in the center, since the entire depth is 600. So the z-axis value will be 300. And then horizontally and vertically, we will also bring everything into the center. Now horizontally and vertically I have already done that. Let's take a look at the setup that we are dealing with here. So we are dealing with one container box in which there are 8 boxes inside, obviously. Now the second container box, we can see it in a moment, so it's all of them are stacked on top of each other at this given point, at least horizontally and vertically on the X and Y axis. They are already, I have positioned them already into the center. Since they are on top of each other, of course position absolute, and I have used those options that we know, the top and the left, using the calculation function in order to get them vertically and horizontally into the center, meaning 50% down, but then negative its height and negative its width, which would ultimately give us these elements to be really in the center of their container box. And now what we will be doing on the first elements, we will be starting the tab number 1. And that tab number 1, let me just change for a moment our blueprint here, right, this one. So that is our first one, the tab that we are now working on. But since all of these elements we will first bring to the center, so let's just apply it here as well. Let's now move it first in the center, on the Z-axis as well. Since we have now already accomplished it on the X and the Y-axis, let's also make that happen on the Z-axis. So since the element is facing us with its front, if we want it further to go away from its back, to further into depth from its back, or further from its back, then we are using negative values. And since our diameter, our entire depth, we define to be 600, so let's move it negative 300 pixels further into depth. So let's go for this one, and of course we need a perspective, otherwise nothing will work. Let's go on the parent container box. Let's give it a perspective so the browser is able to do the calculation how the element would look like if there was actual depth going on. Now this is fine for this one. Now we have it in the center, but now we want to move it out to its actual location. So what we are actually doing here is unnecessary, of course, but just to get the logic, and then we are moving it out. But in this case, all we are doing, we are moving it towards us once again. And that is ultimate. And on the Z-axis, of course, we move it towards us once again. So it has the same look as it was before. Now for the next one, it makes more sense. Let's go for our tab number 2. And that's the light blue one. This one is this one. So we bring it to the center in the depth. Then we rotate it and then we move it out. So that is what we will be doing. And the rotation will be 45 degrees as mentioned. Since we are dealing with 8 elements, 360 divided by 8 is 45. So let's go for this rotation then at 45. So first of all, let's move it out, move it to the center on the Z-axis as well, negative 300 pixels. Let's rotate it, of course, to the right. It's going to the right on the Y-axis, 45 degrees, therefore positive to the right. And then let's move it out, 300 pixels. And that will ultimately make it to be at that location where it is supposed to be. And that is what we will now be doing for each and every one, but we will of course not go over them individually now. Just one more example than the other ones I have already accomplished. So once again, let's bring it to the center also on the Z-axis, 300 pixels. Let's rotate it by 90 degrees, 45 more, and then let's move it out, 300 pixels. And that ultimately will make it right here it is. Now with the other ones I have already done this. So let me comment those ones right here and let me reload the page. Here they go. Here they are. Let me now change also the perspective origin a little bit so we can see it a little bit better. Center is fine, but on the top we want it somewhere. Let's go, for example, vertically only down 10%. And here we have now a better look at those elements right here. What we will now be doing is we will be answering the question now. Why did we actually go for a depth of 600? We could have used any other value, of course. Let us just do that for a moment. Let me now take those and let me change it, for example, to 200. So we want to change the 300 to 200 for a moment. And now let's take a look what happens. Now they are very too close together so that they are actually disturbing each other. How can we find out so that the elements are right next to each other? And once again, there is a little bit of, this time, geometry involved, but we can use calculators for this one. So we are dealing with a pentagon, so a rubbish with an 8-sided one, an octagon. And what side do we need to give it in order to know the radius? The diameter is our complete depth, and the radius is the amount that we used to send the elements to the center. So we used 300 pixels or 200 pixels just, but we want now the actual radius that we need to use so the elements are next to each other. And therefore we need to give it the width. And the width that we have used for those boxes is 200 pixels. So let's insert that, let it be calculated by the calculator, and that will give us the radius. That is then the amount we will be using now, and that will give us now exactly the amount that is necessary for the elements to be next to each other. So let me reload the page, and here we have our elements. The last comment that we will now be making is that the entire procedure that we have done can be done more easily. We have just done it in this way because it is actually an option to make it this way without making use of the preserve 3D value for the transform style property, because this one is not being supported by Internet Explorer. However, it's actually pretty much not possible to not use it anyhow. Things will be made much easier because ultimately, of course, what we want is that entire thing shall be a rotation, of course. And in the current situation, we need to rotate each individually, each element. Let's just rotate the parent instead when an arrow key gets clicked. And also, instead of moving each individually to the center, what we have done at the moment by giving them each individually the translate Z value 241 in this case further to the center, let's just move the parent container box further into depth so that we then not need to move them anymore individually into depth. It's the much easier option, but of course in that case we are dealing with another container box then, and we are making a 3D transformation on the parent also of these 8 boxes, and these 8 boxes are also being transformed in 3D, meaning a parent and a child will be transformed in 3D, so we need to apply that preserve 3D value for the transform style property. So let's do the setup first of all here. It's very, very quickly. So we are now dealing with another container box. That container box will serve as for us also for the perspective, since there is no transformation yet going on, and those 2 properties must always be applied on the outer parent container box. Now here we can leave it this way. Preserve 3D we need, however, since we will now be transforming this one as well. Here we will now be doing the translation on the Z-axis by the amount that we have already found out. So further into depth, meaning negative in this case. And now that is something that we don't need to do here anymore. So let me just remove those ones. The much better option than from the previous example that we had. Just use another container box and rotate that container box instead, and also send this one into depth instead. So let's remove those ones here, and once we have done so, I did something wrong here. Let me just do it once again. And un momento. So right, this one we are searching for, and it shall be replaced of course with nothing, and here we go. And we have now accomplished the exact same thing, but using much less code, and it will be much easier then to also make use of the JavaScript later on when we are rotating them. Since we don't need to rotate them individually, we just rotate the entire container box instead. So that is our first 3-dimensional object. Let's go into the second one. And now we are dealing with a square-like 3-dimensional object, such as, for example, a DVD case, a book, for example. It's always the background images that then make it what it's supposed to be. But any square-like 3D object, let's just make it a DVD case in this case by the background images that are being used here. And let's follow exactly the same logic as we did. Let's first of all bring everything to the center on all the axes, on the X, the Y, and the Z axis. And let's do exactly the same thing, but straight away with the better alternative by using an outer container box and bring that one on the Z axis into the center while this one will also be transformed. So let's do it exactly in the way that we have just changed the last example to at its final stage. So we are using now the outer container box. This one gets the perspective and the perspective origin. Let me actually change the origin at this point. Let me out comment it for a moment. And then the DVD case container, which includes all the individual sides, will now be the one that we will be translating into depth. Now the question, however, is what's the depth in our case, and that of course depends how wide we make the left and the right side and the top and the bottom in its height. So let's make the width, the thickness of that DVD case ultimately to be 20 pixel. Meaning in order for all the sides to be in the center, we need to go for 10 pixel half. So it's on the z-axis right in the center as we have done it before. And here we can see half of it has changed this way, half of it here. However, now let me already change the transform origin actually to a point somewhere outside here, so we can actually then see the element, the 3D effect. Since otherwise the front of the DVD box would be facing us and that's all we would see. So therefore let me already change it. So that would change the container box here as well. Now let's bring, since we have now gotten all of them already into the center on the z-axis by negative 10 pixel, since that is half its thickness, let's go into actually bringing them to the center on the x and the y-axis. So that's the simple thing. The front and the back, they have their own width and height. They have a width, as we can see here, 200 pixels and a height of 300. So since they are already making up the entire height of the container box, all we need to do here, therefore, move them into the center on horizontally. So using once again 50% negative half its width. And now both the front and the back, which have the same size, are now in the center. Let us now concentrate on the next pair. Since of course the left and the right side, they also have the same width and height. So here we have them, the right and the left. The right is currently on the top. And they have a width, of course, since the thickness is 20 pixels, so they have a width of 20 pixels and a height, the same height, 300 pixels. Since it's already taking up the entire height of the container box, all we need to do is we need to center it, in this case, horizontally, once again, using the left property with the calculation function, 50% negative half its width. And that will ultimately bring our elements to the center. Let's concentrate on the last pair, and that is the top and the bottom. They of course also have the same dimensions, and these ones are right here, and we need to bring them to the center vertically and horizontally. So we will be making use of top and left in the same way as we have just done it. So they have the same width as of course as the front and the back. And they have a height of the thickness of the left and the right. What the left and the right have in width, that's the height, of course, here, so 20 pixels. Now let's bring them to the center using the top and the left properties in exactly the same way, and that's where they are. So now everything is in the center, and now let's move them to their actual location where we want them to be, since they are now in the center already on the X, Y, and on the Z-axis. The Z-axis center we have already given on the parent. So what we need to do to the bottom, we need to let it fall towards us, and by 90 degrees, so that its front side is then facing downwards. And then its side is facing downwards, so then we can translate it on the z-axis, which is referring to the front of the side, by positive then 150 pixels. Since the entire height of the DVD box is 300, so we just use half of it, since it's happening right in the center and the transform origin will be happening right in the center. So it's just the easiest way to bring things across, really, by moving everything in the center first. So we are dealing now with the bottom side. So rotate it so it falls towards us. It's negative 90 degrees, and then move it from its front side 150 pixels. Front side is facing downwards, so it will move downwards. Let's go for the top side. Top side, we want to fall backwards 90 degrees. So it's the front side here is facing then towards the top, and then once again we move it out 150 pixels, half the height of the actual DVD box. Let's concentrate on the left and the right side, which are right here. So the right side shall go to the right, so we will be rotating it on the y-axis positive to the right. So its right side is facing this direction, and then we move it out by half the width, which is, in this case, 100 pixels, since the entire width of the DVD box is 200. So that's the right part, 90 degrees on the y-axis, and then we move it out. Now the other one, we rotate on the y-axis to the left, negative therefore, and then once again move it out 100 pixels. And now the final one is the front and the back. Both of the front, all we need to do here is we need to bring it further towards us, since right now on the z-axis it's 10 pixels away. Let's take a look. Let me outcomment actually the back for a moment. So the front is still in the center on the z-axis. All we need to do, bring it now 10 pixels towards us. So that's all we need to do in this case. And the other one, the back side, we need to rotate first, so that it is representing the back. Rotate it 180 degrees, so its front side is facing now away from us, and then move it out 10 pixel, exactly the same way. 10 pixel out, 180, and that finally gives us now our 3D object here, our square-like 3D object. Now at this given stage, this setup was not very useful yet, since of course such a setup only makes sense when we are really viewing that element, viewing the entire square-like 3D object from a different angle at some point, because otherwise we could have accomplished this by just using 3 elements and skewing the top sides on the x-axis and the left element here on the y-axis on the top and bottom sides, and we could have accomplished the exact same thing by using 2D skewing, 2D transformations, just skewing the elements. So therefore, creating such elements really only, such 3D objects really only makes sense once we are really viewing them at one point from a different angle. And therefore, let's just apply a transformation here. Of course, on the container box here, we are not doing it to the elements individually. And of course, now we would outcomment the actual background, and that ultimately is now our box. So only makes sense, of course, when we are viewing it at one point from a different angle, so that we can see that there is a backside. If that was skewed and we are rotating it, of course, we would see, hey, that this is a fake. This is not really 3D. So, of course, in this case, it's really 3D. Let's go into one final example, and the setup that we are dealing here is once again the same. So all of them were in the center on all the 3 axes from the beginning, and then I moved them out already. In this case, we are dealing with triangles. Better said, we are still dealing with square boxes, since we have seen that triangles are just a fake, nothing else, in week number 14. So let me go there. Let me just give it a background so we once again can see it. It's just a square box, nothing else, and the triangle can be created by not using any width and any height. So setting the width and the height to 0, and instead let the width be determined by a border. For the width, it's the border left and the border right that will determine the width. So it's 200 pixels in total, the width that the element has. And the height, I determined it to be right here with the border bottom. The border from the bottom comes from the bottom and determines the height. And that is 300 pixels. So we are dealing with elements 200, 300. And of course, since we are dealing now here with triangles, we want them to then build a pyramid. But the question now becomes, by how much do we need to rotate them? First of all, where shall the rotation now happen from? And of course, they shall be rotated. The transform origin shall be at the bottom of these elements. So that's the first thing to consider, so that they are falling down and they are staying here on that side. Now, the question, however, now becomes what we are dealing with here. We have now the width here is 200 pixels and half the width is 100 pixels. Therefore, of course, the height is 300 pixels, and this is the one that we want to rotate to a certain degree, which we don't know yet, which we still need to calculate. And then finally, we are dealing here with a triangle. So here is our right angle here, 90 degrees. And this side is known here. That's our height. Let me change the color for a moment. So this side is known, 300 pixels. This side is known as well. It's half our width, therefore 100 pixels. So we know 2 sides here And therefore, based on the sides that we want to know, and also based on the angle that we want to know, based on the information that we have, that's ultimately whether we are using sine, cosine, or tangent. And that is trigonometry in this case. So once we know the opposite side of the right angle in this case, and in this case, the opposite side of the angle that we want to know is therefore this one. So therefore, since we know this side, which is the hypotenuse, doesn't matter actually, and this side is the opposite side, since we know that one, we can calculate it now by using once again our calculator. And in this case, since we know those two sides, we need sine. So that's in this case, we need to be familiar with trigonometry actually. It's just the sides that we are familiar with and the angle that we want to know determine which one we are using. And in this case, since the hypotenuse and the opposite side are known, therefore we are using sine. So that is actually an example where that knowledge, where we need actually to explain it actually a little bit further. But let me just accomplish it now. So we are dealing with 300 pixels, that's the height in this case, and we want the ratio of the other side, and that is therefore it's 100 divided by the hypotenuse. It's 300, and once again, it's 100, the opposite side divided by the hypotenuse, which is the opposite of the right triangle. 300 gives us 0.33, and now it's the sine. And it's the opposite, not the sine anymore, but sine -1 here, since we want the angle in this case, not a value, but the angle. And that will be 19.47 degrees. And that is what we need to do. And of course, we are now rotating on the x-axis. We are letting them fall downwards, and we are using a positive values. They are falling down. And the transform origin will be somewhere at the bottom, meaning the vertical value for the transform origin must be 100%. And that one I have already given. Which x value we are using does not matter. So let me just include now this one. So we are also using now rotate on the x-axis, and with a value of 19, and of course in degrees. And something went wrong, definitely went wrong right here. Let me just check this one for a moment. In this case, we needed to stay actually at the center. True. That's true, yeah. Okay, and then sorry for this. And now we can give this one to each and every one that we have right here. And this one will now ultimately give us the result. Since we are dealing with triangles here, they had to be really in the center of it. Now, of course, this one once again only makes sense when we are rotating it at one point. So let's just apply this one here once as well. Of course, not rotating the individual sides, but the parent, much easier. And that ultimately gives us this result. Let me outcomment for a moment the background color here as well. Let us now very briefly go into our final topic, since that one is scaling very briefly done. So we can do scale things on the z-axis, and that is referring to the thickness. And that thickness, of course, does only exist when we have created thickness, meaning when we have created one of those 3D objects that we have just done. And therefore, then we have thickness. But of course, each individual element has no thickness. So therefore, scale z must be applied on the parent, in which the sides are inside that make up the thickness. So on the parent it must be applied always, the scale z function, in order for it to have an effect. And once we are now doing 2 times its thickness in this case, that is what we get. And we can do things simultaneously on all the axes, which are by default 1, which is of course the original size. Let's go, for example, 2, 3, maybe 4 to go for maybe a crazy example. So that is what we can do. And this, of course, obviously makes only sense when we have thickness. And it makes sense in situations, since we have seen that quite some calculations were sometimes involved here, or quite some setup. So sometimes if we really want to change the element, just so in order for us to not go into the setup, change the setup once again, it's quite a little bit of an effort. Why not just scale it? So let's just do it on this pyramid that we have created right here. Let me now also, in addition, scale it for a moment right here on the parent, of course, which includes all the sides that make up the thickness, and then scale it on the z-axis, for example, or let's scale it in 3D actually on all the sides, and let's make it 2, 2, 2, so twice its width, twice its height, and twice its thickness. And that is what we have now. So that's our elements. So that is where scaling can be used, and it must always be applied on the actual parent. The last comment that I want to make now to finish it up is the metrics. Now we have seen it in last week already that what the browser does in order to calculate the new position that each corner of the element will have, it will use a matrix. It will take the original coordinates of the corners of the element and then multiply it by a matrix, which will ultimately then give the browser the actual new coordinates that each corner will have. Let's take a look at this one. So let's rotate it on the y-axis for a moment, and let's inspect this one. So we have just used here for our element the value rotate y 30 degrees. Now if we are taking a look what the browser ultimately uses under the computed values, which are the values that are ultimately taken, here we can see the matrix 3D. And it consists of 16 values, and these 16 values do not only comprise 3D rotation. Sometimes we have used 2D rotation and 3D rotation at the same time. A 3D transformation and 2D transformation at the same time. For example, we have used translate X with combining it with rotate Y, which is a 3D and a 2D transformation. So of course these values also comprise the 2D values once an element is in addition being transformed in 2D as well. So that ultimately leads to so many values that actually exist here inside that function. Now we will not go over the individual values, only very briefly, and how the browser actually calculates it, how it multiplies each corner's coordinates originally with that matrix. We only need to know once we are working with JavaScript on heavier transformation projects. So what I want to mention here, however, is of course the one is always referring to the scale. So that's just the original value that's being used here. And these are just the alpha values as we are familiar with them. These values here are for translate X, Y, and Z. And these can only be pixels. So px units attaching to it is not possible. Then other values, skewing, for example, once again, the values are calculated up on tangent. The tangent results, then rotation is based on sine and cosine. So that's all I want to mention here. If we want more knowledge, inside the notes I have written a little bit more information. But the key thing what I want to bring once again across here is that the browser will always use the identity matrix. Because once the browser, for example, when we are now applying an animation, something that we have discussed last week, when we are applying an animation up on an element that it shall be rotated in 3D, then once the mouse leaves the element again, the browser will not go back to the transform default value. That would usually be the case. The default value is none. And that is not the value that the browser goes back to, because once the mouse hovers over it, it already transforms things, it converts things into a matrix, and when the mouse leaves again, it needs another matrix in order to continue the calculation. So that's the default matrix, the initial matrix that's being used ultimately, the identity matrix that's being used then ultimately. So the point here is that we don't need to change that value then away to rotate 0, since the browser will never use the default value none. In comparison, we have seen it, for example, with let me just once again mention it, with the border. Once we are now applying a border, once we go away, the border immediately disappears because the browser goes back to the default value none, and that is a value that it cannot change to over time. So that one we actually needed to change to solid blue, and then the border is disappearing also when the mouse is leaving the element. Over time it is disappearing. And here comes one comment that I briefly want to make, and that was in regards to our folding image right on top here. This folding image here is working fine. However, there is a bug still going on, and it's not just the Firefox browser. In this scenario, actually, we had to specify when the mouse is leaving the element again, then I had to specify it, translate X and rotate Y 0. Even though, didn't we just discuss, it goes back to it doesn't go back to none, we don't need to specify it. But once I do so, it still works, and in fact, it's sometimes, so in the second time it didn't work. So here is still sometimes a bug, and in some other browsers there are also some bugs in general to 3D when we are working on heavier projects. Such as this one, we could go now, here we can see already first bug, it's not going to the second one in this case. Or if we are going into Chrome, this is very smoothly actually, but once I increase the browser window, here we can see that things will be messed up, and once I reload the page even, doesn't work, the background images that are repeated will not repeat into depth completely. So there are still bugs going on. It's still an early stage that the transformation, the examples that we have gone over are actually fine apart from this little example with the folding image. But in general, it's still in its early stage a little bit, using transformations for heavier things, for things like this, because in general what we could do, of course, we could build another hallway to the left, another one to the right. We could do completely crazy things here then ultimately, and move then to the next hallway and etc. So a lot of things could be done, but due to the early stage that the transformation property is still a little bit too much bugs going on. Therefore, it's a little bit too early to make crazy or even more advanced things. Now this one, what we are dealing with here actually is just a 3D object once again, consisting of a right side, a left side, a back, a top, a front, a back and a top. So it's 6 sides, same as the DVD case basically, just done with the units not done in small, but with viewport width and viewport height instead, giving the dimensions to the elements. So, but it's exactly, once again, just a 3D object here, nothing else, same as the DVD case. So that is it now for our little series that we have gone over. Since over the last 5 weeks we have discussed always shapes and effects. It was all about shapes and effects in the last 5 weeks. Now we are done with it. And in next week we will be going into server, all server related things that go on inside the browser, which includes the links, for example. Once we click it, we are going to the server, get new stuff. What it also includes are all the input fields, text area, checkboxes and all those things, since ultimately they are being used to send information to the server. So that is the topic of next week.